Let's solve our challenge. I've gone ahead and created a brand new playground called multi-line variables and constants challenge solution here. Now let's just go ahead and delete our first line of code here. So we're going to go ahead and create a variable. We're going to say my age equals 30. And we'll create another variable, which say my favorite color equals red. And we'll say I am bald equals false. All right, and one of the things we wanted to do here is we wanted to prove that we're able to change the value of my age, my favorite color, and I am bald. So we'll say my age equals 31. My favorite color is going to be equal to blue. And we'll say I am bald equals. So here we see that I'm able to change the value of my age, my favorite color, and I am bald because these are all variables, and we declared all these variables in the same line. Let's also try doing some constants here. We can say let my father's name equal John, and we'll do my grandmother's name, and we'll set this equal to Elizabeth. And you saw me accidentally add an apostrophe there. We don't want to do that. Just stick with characters and letters for now. We'll get into some of the other things later on, but don't want to add apostrophes there. It could really mess up your constant name there. And we see here that we're able to generate two different constants, my father's name and my grandmother's name, in the same line here, but we can't update the value from something like my father's name because this is a constant, so we can't change this to Matt. It's not possible. So let's go ahead and just delete that line of code, and we've successfully solved our multi-line variables and constants challenge. And my playground here keeps throwing little default error messages, part of the beta version of Xcode. Hopefully they'll revise this for the live version that's coming out. All right, let's go ahead and solve our semicolons challenge here. I'm going to go ahead and generate a brand new playground. And I'm going to call this semicolons challenge solution. And I'll go ahead and select next and create. And I'll go ahead and enlarge my playground here. And I'll delete my first line of code. And let's go ahead and first create a variable. We'll say no semicolons. And we'll set this equal to Swift is modern. And just like the variable name says here, we're not going to include a semicolon here. But let's go ahead and create one called semicolons. And we'll say Swift is flexible. That's one of the great things about Swift, the fact that we do have these variations when people have a strong preference for something. We can also do multiple lines of code. So let's just go ahead and say var one line equals Swift can interpret various commands on a single line, semicolon. The semicolon is important because then we can type print and we can do one line. And if we wanted to, we can even say let this is crazy equals true. So we could actually even assign a Boolean. And if we wanted to, just to see that this exists, we could print this out after, just to prove that we were able to create this constant. And we see that this now prints out to our panel over here on the right because we were able to create this constant all inside of one line here. In this challenge, we would like you to practice using some good constants and variable names. So this isn't an exact science here. We're going to give you some examples in our solution if you want to check that out. But essentially, I'd like you to create 3 constants with sensible names for their value and also create 3 variables and practice using with and without type annotations. So just solidify type annotations. And we would like you to use camel case even though there might be alternative ways to do this for example, using underscore, definitely stick with camel case. We're going to be using that in the course, and it'll be really good for you to be familiar with that. So we have our multi-line variables and constant challenge. Once again, I want you to solve this in the playground, and this is just a chance for you to make sure that you understand how to create multiple variables on the same line. So create different variables on the same line and prove that they work by updating their values. So you can update their values one at a time. We also want you to create different constants on the same line, and you can't prove that they work by updating their values. That's not possible because they're constants, remember. So just remember that you can mix declaration of different types of variables or constant types on the same line, but you can't just kind of add variables and constants simultaneously. It's time to learn about one of the most handy tools for figuring out how to write code, debugging your code, and just generally figuring out what's going on in your computer program. And the topic we're going to be covering is print. Now, print, according to Apple, is a global function. That means it's accessible to us wherever we are. That's all we need to know about global here. And it prints a value followed by a line break to an appropriate output. So we're going to see that our output will be different in Playground versus Xcode. We're going to go over both examples together. And basically what this allows us to do is just print out the value for a given variable or constant. We don't necessarily need to input a variable or constant, but that is an option. And in our example that we have here, we're not printing out a variable or constant that was declared ahead of time. We're just going to go ahead and create a value here. So we see that we have a string here, and we just insert it inside of our parentheses here. And we have this keyword print ahead of time. And this will go ahead and actually print this is a string, or actually display this is a string in the proper console output. So let's go ahead and just try to give you a quick analogy about print before we see it in use. We can kind of think of print as a diagnostic read. So I just kind of have a little picture of that there. It's also like a console output. Let me use this example. Imagine you had a car and it was broken, right? There's something wrong with the engine. How would you figure out what was going on wrong with it? Well, you take it into the technician, and modern cars are basically just giant computers. So you'd plug it in and you'd see, oh, this thing is no longer working. And it would print out and it would tell you, okay, well, that nozzle is the reason my car isn't working. Well, print basically allows us to do that. Print is the tool that allows us to say, okay, check this nozzle, and then we could go check the next nozzle, and so on and so forth. Print allows us to check values of variables and constants inside of our computer program.